here. So uh, they will be giving some number of tokens, and we will be using two parameters k and b so that we can determine the vocabulary size. So k and b are the typical values for parameters, where k equal to the value ranges from 30 to 100 and b approximately 0.5. Okay, and the fit is excellent for t greater than 0. So when the number of terms are greater than 10 to the power of 5, then normally we use k equal to 44 and b equal to 0.49. So this also uh, we have completed in our last class. And example, we have seen how to determine the vocabulary size and zip slow. So for zip slow, it's regarding the distribution of the terms. So how we are going to distribute the terms is been discussed using Gibbs law. Gibbs law states that if T1 term 1 is the most common term in the collection, term 2 is the next most common term, and so on, then the collection frequency of the most common term is proportional to 1 by I. So 1 by I is not so there is an inverse relation. Okay, so if your rank increases, then it is your frequency will be decreases. If your frequency, document frequency increases, then your rank will be decreases. So that is what it shows an inverse relation between these two terms. And one second. Okay, so that is the example is shown here. Rank when there are more number of words for the, if you consider this as a term, and this number of frequency is there in the collection, so its rank is 1. It is the highest frequency, so highest frequency is maximum number and rank is 1. So this is the list number. So it is inverse relation. And of it is another term, this has rank 2 and this number of document frequency. So this we have seen, and the calculation also we have seen here. So using this one we have seen the calculation here. So I think all of you have done this example. In last class I have asked you to solve this one, whether you get the same answer or not, in order to check it. Always the value for R into PR, rank into probability, will be equal to A. A is some constant and its approximate value is 0.1. So you can check from here 0.06, you can round up and it will be almost similar to 1. 0.05, since it is 5, it can be rounded into 0.1, and 0.07 also can be rounded to 0.1. 0.09 it can be rounded to 1. 0.11 it can be rounded to 0.1, like this. Okay, so all this we have checked it, and we got a value similar to 0.1. So I have done calculation only for rank 1 and rank 2, and last class I have asked you to calculate for the remaining terms. Okay, now so we will see dictionary compression. We will see now dictionary compression. So here in the figure we have some term here, we have some document frequency and pointer to the posting list. So for this storage, for every term we need to store in the memory. So for storing in the memory, how much space needed, it has been given in the table here. For the terms, we will be requiring for a single term 20 bytes. and for the frequency 4 bytes, and for another frequency for the pointer it will require another 4 bytes. So total this example, some Zulu, some terms are written here, some dictionaries are written here, and already I told you these terms which we have been writing here, it is extracted from reuters. Reuters is some text information available online. From that we have retrieved the information, and we are writing the table here. Okay, so for this particular table, for the terms we need 20 bytes. For the frequency storage we need 4 bytes. For the pointer storage we need another 4 bytes. So total space required for storage is 20 bytes plus 4 into 4 lakhs. 4 lakhs is nothing but total number of terms in the Reuters text information. So we get around 11.2. One second. So we get around 111.2 MB of storage capacity. Okay. So the size of the storing size for storing this information, it is about 11.2 MB. Okay. So this figure storing the dictionary is an array of fixed width entries. One second. Then, using the fixed width entries for terms is clearly wasteful, because for sometimes your term may be very short and sometimes you may have a longer string. Okay, so if we use a fixed width, then it may waste some of your memory, because all the terms may not have the same length. Okay, so we will be the average length of an English of a term in English is about 8 characters. So average length is 8 characters. So on average we are wasting 12 characters in fixed width scheme. So if you use a fixed width scheme, then we are almost wasting 12 characters, that is 12 bytes, because for a term we will be utilizing 20 bytes. Clear? For a term we will be utilizing, so you hear, for a term, even if it is a short term or long term, short string, the length is short, the length may be long. So for every term we use a fixed width. If we use a fixed width, then what will happen? We may waste about 12 characters. That means about 12 bytes we may lose, because an average length of a term is about 8 characters. So on an average, it is 8 characters. But for every term, if we use 20 bytes for storing it, then we will waste about 12 bytes for every term in the collection, right? So how to compress this one? For this we will be using a technique for dictionary compression. So once again let me explain this. So this Reuters is some text information uh, which we are referring for our calculation purpose. So in Reuters there are about 4 lakhs terms. Okay, 4 lakhs terms. So for every term, if we use a fixed width entry, then अरे यार नानु सुमाने yam disturb तौरक्पसे को Abhijit and Harish Kumar. Okay, so uh, for every term storing, we need 20 bytes. We consider 20 bytes as fixed width entry. And for document frequency, we are going to use about 4 bytes. And for pointer we are going to use about 4 bytes. So you can see here, if we use a fix with entry, then the term average length of an English term is about 8 characters only. So normally, if we use 8 characters out of 20 bytes, if we use 8 characters, that means 8 bytes we use, we have wasted 12 bytes. Okay, so we come here. We have no way of storing terms with more than 20 characters. Like also one disadvantage for this kind of storage, fixed with entry storage or fixed with scheme, is that if the word is more than 20 characters, for example, hydro, chloro, fluorocarbons. So this is more than 20 characters. And there is another word which is very long here. So we cannot store such terms in this type of scheme, fixed with scheme, because we have only 20 characters for term storing. But this is more than 20 characters. So it will take up to only 20 bytes and the remaining will be ignored or it will be discarded. So the actual meaning will be lost. Clear? So this scheme has such disadvantages. Initially, what the advantages we have? We are wasting about, on an average, about 12 bytes using fixed with scheme. And the other one is for uh, characters which are words or strings which are having more than 20 characters, we cannot store it in fixed with scheme. So we can overcome this shortcomings by storing the dictionary terms as one long string of characters. Okay, so we can overcome this by storing the dictionary terms by storing the dictionary terms as one long string of characters. So we will see that. So we are considering dictionary as a string. Okay. So one long string. We will be considering the dictionary terms as one long string. Okay. Now you can check here. Style. There is, you consider this as a long string, and in this string we have stored the terms. Okay. So you can see the pointer in S. So until this new pointer, so the previous one here E, up to E is one term. Okay, that means if you pointed here, then the first term will be before that one, before S. So cystine. So if you point here, if the pointer is here, then it starts a new term. Okay, if the pointer is here, it starts a new term. Similarly, when you can check here the third one also from S. So that means from S, it starts a new term. Here also another S, it starts a new term. So like this, when you consider dictionary as a string, a long string, all the terms will be written together like this. And there will be pointers to point and separate the terms, to point and separate the terms. Now, let us check. There is one word style. There is another word. What is this? Uh, Syzygetic and syzygeal. So there are some words here. You can just check it. So now, sorry, where is it? Where is it? Okay, dictionary as a string. So let us check now. Frequency, posting pointer, term pointer. Frequency, posting pointer, and term pointer. So for frequency, we have 4 bytes, similar with the fixed bit scheme. In fixed bit scheme also, for frequency we have 4 bytes. So when you consider dictionary as a string also, we have used for frequency 4 bytes. And for posting pointer, we have used 4 bytes. Same with this one, for posting pointer, pointer to posting list. Okay, this is posting pointer. We have used 4 bytes in fixed with scheme. Similarly, when in dictionary as a string scheme also, we use posting pointer 4 bytes. But for term, we use only the pointer storage. Only the pointer storage. Term pointer. Initially, what was it? We have written only for term, and for term it occupies about 20 bytes fixed for every entries, for every terms, long or short length. We are going to store 20 bytes. We are going to use 20 bytes for storing. While in dictionary as a string, what we have done is, instead of term storage, we have used a term pointer storage. Pointer storage, it reduces the size. So initially it was 20 bytes, but since we use the pointer storage only, because we are going to point here, right? So only this pointer storage we have used, and for this it is only 3 bytes. It occupies only 3 bytes for term pointer. So automatically this reduces the size of the dictionary, reduces the size of the memory storage, right? So initially it was about 11.2 or 3 MB, right? And for this you can easily calculate using the pointers here, and you can get uh, a lesser size of the this one, memory, storage memory. Okay, so now when you consider dictionary as a string, this has reduced the size of your storage capacity. So because for term, initially we use 20 bytes in the fixed width scheme, but here we don't use 20 bytes because we are going to use only the term pointers. So for pointers, term pointer storage, we need only 3 bytes. So automatically the size will be reduced. So dictionary as a string storage. So this technique, dictionary as a string storage, pointers mark the end of the preceding term and beginning of the next. For example, the first three terms in this example are systile, syzygetic, and syzygial. Okay, so this systile, syzygetic, and syzygial. First three terms, one, two, three, syzygial. Another one is Syzygy, something is there. Sygy, Zy. So, and from this another term is starting. SZAI, like this, and it goes on. Okay. So, with this, since we use only the term pointer storage, the size is reduced from 20 bytes to 3 bytes. So our size is reduced. So dictionary as a string, one technique. So we can check here 4 bytes per term for frequency. For frequency, we use 4 bytes. For pointer to posting list, we use again 4 bytes. And 8 bytes on average for term in string. 8 bytes on average for term in string. We are using only the average number of uh, average length of the word of the term, that is 8 bytes. As I told you, in English word, the average length of the word is 8 characters. So 8 bytes. Now 3 bytes per pointer into string. So the term pointers resolve. You can see here 4 lakhs into 8, which is equal to 3.2 into 10 to the power 6 positions. So they need to be, so there is some calculation, 22 bits or 3 bytes long. 22 bits or 3 bytes long. So in this scheme, we got about 7.6 MB. Initially, it was 11.2 MB. So once again, let me explain this. In dictionary compression for fixed width scheme, this is one scheme, okay, fixed width scheme. In fixed width scheme, for every term, we require 20 bytes. And for frequency, we require 4 bytes. And for pointer to posting list, we require another 4 bytes. So, what is the total size when we refer the text information from Reuters? We have about 4 lakhs terms in the Reuters text information. So when you calculate, we got around 11.2 MB. 11.2 MB. The size is about 11.2 MB. So what is the disadvantage for fixed width scheme is that since we use a fixed width for every term, if it is long or short, we are going to use 20 bytes. But on an average, the length of a term in English is about 8 characters only. There are few words which is more than 8 characters. Okay, there are words more than 20 characters, more than 10 characters, but we don't use them frequently. So on an average, in general, the average length of an English term is approximately 8 characters. So which means only 8 bytes. So when we store 20 bytes, we are going to waste about 12 bytes. Okay, when we use 20 bytes as a fixed width scheme, we are going to waste about 12 bytes. So what is another disadvantage? That is one disadvantage, wasting the memory size. Okay, was wasting the memory, that is one disadvantage. Another disadvantage is sometimes, in some cases, there are words, there are terms greater than having number of characters greater than 20 characters. So in that case, we cannot store the words. Okay, we cannot store the words. So hydrochlorofluorocarbons, this is more than 20 words. So we cannot store this. And this one, it's very long to pronounce. Supercalifragilistic expialidocious something. Okay. So for this word also, it's more than 20. So this word also we cannot store. So we don't oftenly use this word, but sometimes when we use this word, we cannot store it in the memory. So this is another disadvantage. So we use one technique to overcome this. The first technique is using dictionary as a string. Using dictionary as a string. So when you use dictionary as a string, we are going to store all the terms in a long string. Okay, all the terms in a long string, and each term will be separated by giving a pointer to the beginning of the word. So this beginning of the word, we are giving a pointer. Beginning of the word, we are giving a pointer. Beginning of the word, we are giving a pointer. So for giving this pointer, we require 3 bytes. So this requirement of 3 bytes calculation is done here. So 3 bytes long. So how do we say the term pointer requires about 3 bytes? So term pointers, since we have 4 lakhs terms and we have on an average of 8 bytes for an English character, for an English term, we require about on an average 8 bytes. So we multiply this two, and there will be on an average we are going to utilize this much of positions. Okay, this much of positions will be utilized. So when we calculate for pointer, we are using this formula, log of this result. So log of this result It gives around 22 bits, which is similar with 3 bytes long. So that's why we are telling that the term pointer approximately requires about 3 bytes for storage. Magdalene, roll number 30. So we require about 3 bytes. Now, here the calculation we are going to start for how much storage is needed. In fixed width scheme, we need about 11.2 MB. Now, we will calculate for dictionary as a string scheme. For this scheme, so as I told you, we use Richter's dictionary text information. From this text information, it has around 4 lakhs terms. 4 lakhs terms is written here. Then 4 bytes for frequency, 4 bytes for pointer to posting list, 3 bytes for term pointer, and on an average for an English character we use 8 bytes. So we are going to add this, multiply with this value, and we got 7.6 MB. Okay, so the size has been reduced. Initially, the space requirement for fixed width scheme is about 11.2 MB. Now it has been reduced when we use dictionary as a string to 7.6 MB. Okay, so 1 by third, around 1 by third, we have saved the memory. Now another scheme is there, that is block storage. This another scheme name is block storage. Okay, so all these schemes you remember. First one is fixed width, second one is dictionary as a string storage, and third one is block storage. So in block storage, so what we are going to see here is we are going to compress the dictionary by grouping terms in the string into blocks of size k, blocks of size k, and keeping a term pointer. Here also we will be using a term pointer only for the first term of each block. So when you have 5 blocks, then term pointer will be only 5. So inside a block you may have some n number of terms. Okay, so one block may contain 5 terms or 4 terms. Okay, may contain 4 terms. So if you use 5 blocks, then there will be 5 term pointers. Okay. So we compress the dictionary by grouping into string into blocks of size k and keeping a term pointer only for the first term of each block. Only for the first term of each block. Let us see the example. So first you see down here block storage with 4 terms per block. So in each block there will be 4 terms. In each block, there will be 4 terms. The first block consists of systile, syzygetic, syzygial, and syzyg with length of several 7, 9, 8, and 6 characters. So systile has 7 characters, syzygetic has 9 characters, syzygial has 8 characters, and syzyg has 6 characters. Okay. Next, each term is preceded by a byte encoding its length that indicates how many bytes to keep to reach subsequent terms. So you can see the pointer here 7. So before system I am writing 7 here. So this 7 indicates the size or how many characters that particular term has. So since system has 7 characters, we are writing here 7. Then system. Then again we have syzygetic. Since syzygetic has, this is also just like your dictionary as a string. We are considering the long number of terms as a long string, but we are separating or dividing into blocks. Okay, in the same thing, in the same string, we are just dividing into blocks, just like block sort based storage. Just like block sort based storage, we are also just dividing the long string into blocks of size k. Okay, then we are putting the number of characters each term has in front of the term, and in that particular byte we are going to put the term pointer. So 7, we are putting the term pointer here, and systile has 7 characters, we are putting the pointer here. Okay, so since the first block contains 4 characters, in other pointers we are not going to, sorry, in other words we are not going to put the pointers. That is what it is said here. Where is it? By grouping the string into blocks of size k and keeping a thumb pointer only for the first term of each block. Only for the first term of each block. So since this block contains 4 terms and systile is the first word, first term, we are giving the pointer here in the first term, that is systile. So since systile has 7 characters, we are giving the pointer here in 7. Now, systole one word, syzygetic one word, syzygial one word, syzygy one word. So, 4 terms are there in this block. Now, we are starting the second block. So, since we start the second block, we will be using another pointer here at the start of the uh, block, each block, at the start of the each block for the first term. First term. So, Jibel, Yite, Jibel, Yite, something. Okay. So, it has around 11 characters. So, 11 characters, we are giving the pointer here. And so on. Okay, and so on. So, number of term pointers will be reduced here. Number of term pointers will be reduced here. So, we will check it. So, we can further compress the dictionary by grouping terms in the string into blocks and of size k and keeping a term pointer only for the first term of each block. So, this one is already explained in here. And there is a note in dictionary as a string storage, pointers mark at the end of the preceding term and the beginning of the next, while in block storage, it uses a term pointer only for the first term of its block. So this is what I have explained here. So this is the first term for this block. This block contains 4 characters, sorry, 4 terms. This block contains 4 terms. What are the terms? Style, syzygetic, syzygial, and syzygy. So this 4 is contained in one block. So in this block, this is the first term, systyle. Systyle is the first term. So we are giving the pointer there. And another one starts from here. Okay, from here. So the first term is this one, which has 11 characters. So we are giving the pointer here. While in dictionary as a string, so for every term we are giving the pointer. For every term we are giving the pointer. So automatically the term pointer will be more in dictionary as a string and less in block storage. Okay. So you can see here. So the same thing is written down here, and term pointer we are giving here, and since we don't give term pointer for the second word, for the third word, and for the fourth word, we don't give any term pointers. So initially for each term pointer there is 3 bytes, right? So 3 around 9 bytes we saved in block storage. Okay. Initially, what was the thing? For every term, we are going to give the pointer, and for every pointer it requires about 3 bytes. So since if it is single dictionary as a string, then 3 3 3 3, so there will be 12 bytes. 3 3 3 3, 12 bytes. But in block storage, we are giving the pointer only at the first term of the per block, each block, if there is 5 terms, then only for the first term we are going to give the term pointer, and if there are 4 words also, only for the first term. It depends on how you choose the block size. That's why it is said here, grouping terms in string into blocks of size k. Okay, so according to this example we have discussed here, this per block it contains 4 bytes. Sorry, 4 terms. Okay, per block it contains 4 terms. So based on that, since we give the term pointer only in the first term, we are going to save 3 3 3, 9 bytes. So we are going to save 9 bytes in block storage. Okay. Now calculation we can check here. So we thus eliminate k minus 1 term pointers, but need additional k bytes for storing the length of each term. Why length of each term we need additional k bytes? Why? In block storage you can see here 7, we can see here 9, we can see here 8, we can see here 6. So the uh, number of characters, the corresponding byte has been written in front of the terms. So we need additional bytes for storing these numbers. Okay, that is what it is said here. We need an additional k bytes for storing the length of each term. Now, for block size k equal to 4, when k equal to 4, if there are 4 terms in each block, 4 into 3, 4 into 3, 12 bytes for term pointers. Okay, for actual, if there are 4 terms, and for every term pointer, if we require 3 bytes, then 4 into 3, 12 bytes. So 12 bytes is required for the storing. But we save k minus 1 into 3, that is 9 bytes. We save 9 bytes, you can see here. Actually, already I have explained here. For every term pointer in dictionary string, see here, this is 1 3 byte, 1 3 byte, 1 3 byte, 1 3 byte. So you consider for this first 4 term, so 3 3 3 3, 4 times, right? 4 into 3, 12 bytes. But here 1 2 3 4, so here we use only one pointer, so that means only 3 bytes has been utilized, another remaining 9 bytes is saved. Now that is what k minus 1 into 3, so 9 bytes we saved using block storage, but need additional 4 bytes for the term length. Term length means number of characters. We are giving some numbers like 5, 9, 7. Some numbers are giving for the length of the character. So for that we need additional k equal to 4 bytes. So 9 minus 4, actually we set 9 bytes, but since we have to spend another 4 bytes for storing the term length, we are going to subtract from what we have saved. We have saved about 9. We are going to subtract what we are going to use, that is 4 bytes. So remaining 5 bytes are saved for 4 term block. So for each term, we have saved only 5 bytes. Initially, the actual thing is we have saved 9 bytes, but give since we put the term length in front of each starting first term, additional k bytes has to be spent. So for every by another 4 bytes has to be spent. So 9 bytes was actually the number of bytes we saved, and 4 bytes is what we are going to spend for term length. So 9 minus 4, which is 5 bytes. So every block we are going to save only 9 bytes. It has to be 9, sorry, it has to be 9 bytes, but for every block we are going to save only 5 bytes. Okay. So, or you can either calculate how much you can save here in this way also. 12 bytes minus 3 plus 4, this also you can do, or this also you can do, same thing. Okay. So what you have to remember here is we saved 5 bytes for every block. Okay, for every 4 term block we saved 5 bytes. So the total space requirement for block storage is, it will be reduced by 5 bytes per 4 term block, or 4 lakh terms into 1 by 4 into 5. That means there will be 1 by 4 is because for first term out of 4 terms, the first term only we are going to use, and 5 bytes is the reduced bytes. So we got around 7.1 MB. Okay, if the term length is not used, this might be more, this might be lesser, but since the term length is required for block storage, we reduce but not much. So, uh, dictionary as a string storage, it was 7.2 MB. Now it has been reduced to 7.1 MB using block storage. Okay. Example we will see tomorrow, because this explanation is again, it will take time. For example calculation we will see tomorrow, but once again let me go through what we have done today about block, where is it, dictionary compression. About dictionary compression, so listen very carefully. Dictionary compression, when the size of the dictionary is more, obviously we need to reduce the size of the dictionary, but we need all the terms, but using some techniques we are going to reduce the size so that we can save in our memory. So there are 3 schemes in dictionary compression. The first scheme is the traditional scheme, which is fixed with scheme. So using this scheme we are wasting a lot of memory space. How? Because for every term, long or short length, we are going to spend 20 bytes fixed. Okay, 20 bytes fixed. Document frequency 4 bytes. Another pointer, storage pointer to posting list, another 4 bytes. So when you calculate the total space requirement, it is about 11.2 MB, which is more, much more. So for a 4 lakh term word, 11.2 MB, we consider as it occupies more storage. Okay, and also simply we are investing 12 bytes for every character. Suppose A. A is only 1 byte, right? But we are going to spend 20 bytes. So 19 bytes we have wasted. Now you can check for the second word, a chain, 1, 2, 3, 4, 5, 6. Only 6 bytes. But we are going to spend 20 bytes. So remaining 14 bytes has been wasted. And the next word, Zulu. Zulu only 4 bytes. 4 bytes we need, but what's the problem here? We are going to spend 20 bytes. So another 16 bytes is simply wasted, right? So like this, on an average, we have wasted for every term around 12 bytes, 12 bytes, 12 bytes for every term. So there are 4 lakhs terms, and if we have wasted 4 lakhs into 20 bytes, right? 4 lakhs into 20 bytes, but suppose if we are wasting 12 bytes for every term, then you can just subtract and see how many bytes we have wasted. Okay, how you can subtract 4 lakhs into 20 bytes minus your this one. 4 lakhs into your how many 12 bytes, 12 bytes. So you can just get the result how many bytes you have wasted for storing the uh, this term in the memory. So like this, in order to overcome this, we have dictionary as a string. And one more disadvantage for dictionary compression is when you have word more than 20 characters. We cannot store this in fixed with scheme because our memory will take only up to 20 characters. Okay. So another disadvantage. Now we have dictionary as a string. One technique, dictionary as a string storage. For this we are going to consider the term, all the terms in the collection as a long string, and we are going to separate the terms by using a pointer. Okay, by using a pointer we are going to separate, and so for every pointer which we use for separating the term, it requires about 3 bytes. So 3 bytes calculation is from here. Okay, so now we will check the storage. So we have about 4 lakh terms. So 4 bytes for frequency, 4 bytes for term pointer. On an average, we are taking about 8 bytes for an English term and 3 bytes for term pointer. When you calculate this, we got 7.6 MB. 7.6 MB. So using the fixed width scheme, we already got 11.2 MB. Now using dictionary as a string, we got around 7.6 MB. And we have another technique known as the block storage. Here, the concept is similar with block short-based indexing, which we have done in last classes. So in block storage, what we are going to do is the concept is same. The string remains the same. Okay, the string remains the same, but we are going to perform some grouping of the terms. Grouping of the terms can be done using blocks, like blocks or base storage. Okay, so we are going to group the terms in the string into blocks of size k, into blocks of size k, and we are going to use the pointer only for the first term of each block. So we are going to use the pointer only for the first term of each block. So let us consider this example. According to this example, the block has 4 terms and we have the pointer here in the first term. Okay. Now, calculations. So there are 4 terms. Suppose it was to be 4 into 3, 12 bytes was to be utilized for storing these terms. But since we are using the pointer only for the first term, so pointer for these 3 terms has been saved. So that means 3 bytes for this term, each term. 3 into 3 plus 3 plus 3. So 9 bytes has been saved using the block storage. But what happened? We are using the term length here. We are giving the term length here. So style has 7 characters, so 7 bytes. So Zygetic has 9 characters, so 9 bytes. So we are giving the term length here. So for storing the term length, we need additional bytes. Actually, we said 9 bytes, right? But since we use the term length here, we are going to spend another 4 bytes. So spend the 4 bytes, 9 minus 4 bytes, we have saved only 5 bytes. That is what it is written here. We have saved only 5 bytes. Okay, so now total space requirement has been calculated here. So it is calculated since we use only one term out of 4 terms, 1 by 4 into 5, what we have saved here. So the total 0.5 MB has been reduced in total. So that means it was 7.6 MB in dictionary as a string, while in block storage we bring down the size into 7.1 MB. Okay, so let me send the material. You go through once again and we will do the examples in our next class. Okay, so this is the example searching for the uncompressed dictionary, and after compressing, searching will be performed and we will be calculating the size for the uncompressed dictionary and size after compressing the dictionary, and we will compare the two results. This we will do tomorrow. Okay. And front coding is also one more technique we will see in our next class. So before that, let me take a quick roll call. Roll number one,
Present, ma'am.
roll number two,
Present, ma'am.
roll number three,
Present, ma'am.
four,